strength value. We just ask, you know, who is first, who's the strongest? Well, the strongest is usually the strongest in this area. So who's the next? Oh, well, this gets us closer, right? So
it's a relationship between the intensity of the strength and the the actual schema itself, the actual the picture that you have of the room itself.
Yeah.
Could you add GPS data to your existing data set to get an even more accurate picture?
Yeah, we've actually we've got it. There's no GPS inside here. This latitude, longitude. Every time that we do a scan, if my Bluetooth GPS unit is hooked up, it's just collecting the number of satellites, latitude, longitude. And so we can use that if, let's say, there are 8 satellites out of a possible 12. We can again infer a little bit about the bias. We can bias the GPS signal based on how strong or accurate it's supposed to be. We looked. I checked over in Bissell. I checked on the 7th floor, and I had 9 satellites with a GPS coordinate that put me down over at the stoplights at Harvard and St. George. And that's 9 out of 12 satellites. It should be pretty accurate. Whereas with the Wi-Fi, it actually located me inside the circle, which we've figured out for that building anyways, was about a 2.5 meter diameter.
So in that case,
far more
GPS
accurate.
was really bad.
Yeah, but we're collecting the information regardless, because it would be ideal to convert this XY coordinate in pixel values into a GPS coordinate anyways. And that way users can tie into something like, let's say, a Google Maps to tag a location, to add information that somebody else can come along in the future and see various points that people have been, they've left some information for somebody else.
So I guess the most important message is that this represents the very basic engine of getting position out of Wi-Fi access points, and then you know there's all sorts of services that can be built on top of that. So we've tried to take into account as much variance as much variance of services as possible. So as Jamon said, you know, collecting the GPS signal even if it's not available, so that people using this engine can provide their own services. Right?
We've also tried to make it small, and it's using WX Python, which runs on Mac, Linux, and Windows as well. So we've tried to make it, ideally we could run this data collection tool where the user doesn't necessarily see a map, but it can still collect information about their location. It would be great to run it on a cell phone or any other mobile device that's capable of running Python. Anything with Wi-Fi should be able to run this tool is what we're after. Any other questions? Yeah.
Looking at this map, you've got the 3 rings there which represent one data access point.
It represents our location.
Right.
Well,
with regard to, okay.
I guess of our location.
I was wondering, you've got 3 different MAC addresses up there.
Mm-hmm.
So this doesn't actually identify, or it doesn't display where the access points are.
No,
We actually don't know.
Because, like I said before, people move them all the time. You'd think like they hang them up on top of the wall, and it doesn't move. But there was a talk down at Computer Science a couple months ago, where someone's doing her PhD on this, and she had 14 access points on one floor, and found from day to day that they were moving by 5-10 feet. Each one of them, people were they were moving them off their desks, they were taking them off the wall and putting them somewhere else. And she was trying to do this with triangulation. And you were sort of hinting at this, Jan, that it would be great to be able to locate a person in a particular room on a floor plan and maybe help them navigate in real time, I think is what you were...
Well, I just was thinking you could maybe help if you got the maps, right? So you can, you could do something like add a weight to any scans that you've done in a room, and so say, well, because you're doing neighboring scans, right? And instead of bias a scan on the basis of where you go to walls, I think it's complicated, but it might be something you can do in the future.
We thought about using orientation, maybe using your body as a shield and just doing like a swipe, like doing a rotation and maybe using
No, I haven't thought about that. That's a good idea.
It might look kind of funny, but
The thing is, that's not the only rise that might happen, because even if we do the scan, the results most of the time are
so it
different.
comes
There's
out
never
more.
exactly the same
Yeah.
result, and that's why the order that we use is actually more consistent, much more consistent, because in a certain point, the access point that we see being the strongest is usually stays the strongest due to the repeated scans in the same point, and the order is more consistent than the actual.
It's really interesting, yeah.
Like we discovered between Yura and I, we both have a computer with an Intel wireless chipset. You'd assume that was pretty generic and standard, and we would get vastly different results just based on the timing of the scan. So no two wireless cards are ever going to be the same. That's another piece of variability that we've tried to just factor out. Just take as much information as we can, just grab it all, and do all the data computation later. Don't discard anything.
And that's in terms of the strength, the signal strength, right?
That's in terms of access points that show up. If we don't leave the scan running long enough, Yura's computer would see one more or one less access point that was it had a perfectly good signal strength. It's just that the timing of the way access points are broadcasting their signals and the way cards are scanning, they have to match up at some point to actually catch the beacon packet to say that the access point is there. So we just have to do a scan that takes 20 seconds instead of 5 to make sure that we've got a list of all the different points that are available.
So how can we protect what you've done from patents and things like that?
It's all GPL3 already. So because we wrote all the code from scratch, there were no libraries that we had to worry about using that. It's all just GPL3.
And this is going on YouTube or something?
Yes.
Any other questions?
I kind of missed this earlier. You were saying you collected data points and you used that for information later on.
Mm-hmm.
How did you collect them?
Well, so Linux, I don't know if I can do a basic scan and show the data. There's my data right there. So it's just a basic, it's a utility that's been around in Linux for 5, 10, I can't remember how long it's been around, but it's just a simple command line tool. It gives us the access point. We don't even care about the channel that it's on. We just need the access point, and we do keep the signal level. Not the quality, because that's different amongst every other wireless manufacturer. We don't care about the noise either, which is something that some other people have tried to do. They've tried to factor in noise, but again, an elevator going up and down in the building, or people standing around, your orientation, it changes the noise so much that it's just not even worth considering. And also, Jorge had a work-study student over the summer build a tool that would collect data on Windows that looks exactly like this. We called it Blindsider. And so it's just a simple EXE. I've tried to get the basic